All right, we're going to be looking at graphing quadratic equations here. The graph of a quadratic function is called a parabola. There are three forms: standard form, vertex form, and factored form. Feel free to pause anytime you need to. You should recognize factored form because you'll have some sets of parentheses, things that are being multiplied together. The vertex, we'll get into it a little more later, but h and k is the vertex. And then standard form, highest to lowest exponent, just like we would write standard form for a parabola. For a polynomial. Same idea here in equations. If a is positive, the graph opens up. If a is negative, the graph opens down. All quadratic equations have a vertex, which is the turning point of the graph. All quadratic equations have a vertex, vertex, which is the turning point on the graph. They're symmetric across the axis symmetry, which runs through the vertex, and the formula for the axis symmetry is x equals negative b over 2a. Because we'll be focused on quadratic functions, the axis symmetry is always going to be a vertical line. So that's why we'll see x equal to a number for the axis symmetry. A quadratic function crosses the y-axis once. The y-intercept will always have an x value of 0 because it's on the y-axis. If it's in standard form, we can write it as the point 0c. Quadratic functions crosses or touches the x-axis either 0 times, once, or twice. So 0, 1, or 2 times. For this particular graph, it's really hard to spot the vertex. The vertex would be right here. So that's where the vertex would be. The axis symmetry, that is one that we could write easily. That's x equal to 1, so vertical line. Y-intercept would be where it crosses the y-axis. It'll be some decimal, or you could write it, I guess, as a mixed number. The x-intercept, those will be some decimal values as well. So you'll see one there, and then you'll see one here. Now I'm going to give you a graph of a different one. It's not on your notes page. I had forgot to change it to something that's easier for us to look at as far as integer values. All right, so if we look at this one, we've got a vertex. That's the turning point on the graph at 1, 2. From the origin to the right one up 2. Axis symmetry goes through the vertex, so that'll be this line, x equals 1. Y-intercept is the place where it crosses the y-axis, which happens to be the point 0, 0. And then the x-intercepts are the place where it crosses the x-axis. We've got two of those, 0, 0, or 2, 0. Graphing this in standard form, the a is 4, b is negative 8, c is 1. Axis symmetry, x equals negative b over 2a, so we can write, we've got a negative already, negative 8 over 2 times a, which is 4. The opposite of negative 8 is positive 8. 2 times 4 is 8. 8 over 8 is 1. So axis symmetry, x equals 1. To find the vertex, we're going to plug that 1 back into the equation. So anywhere there's an x, let's put 1. So to find f of 1, the y value at 1, let's plug it in. We'll use order of operations. 1 squared's 1, 4 times 1. All right, we did our exponents. Now we still have multiplication. And so we'll have 4 times 1 is 4, negative 8 times 1 is negative 8. Add and subtract from left to right. 4 minus 8 is negative 4 plus 1, negative 3. So we have a vertex at the point 1, negative 3. Oh, 1, negative 3. So we've already done part of this. A was the 4, B was the negative 8, C was 1. If A is positive, it opens up. If it's opening up, like this, then it'll have a minimum point, a lowest point. Axis symmetry, like we said, was x equals 1. Y-intercept is the place where it crosses the y-axis. 0c. If you put 0 into this function, everywhere there's an x, put 0. Zero squared 0, 4 times 0 is 0. Negative 8 times 0 is 0. 0 minus 0 plus 0. Oh, sorry, plus 1. 0 minus 0 is 0, 0 plus 1, 1. So when you put 0 in, you get 1 out, so that is the y-intercept. Like we said earlier, if it's in standard form, you can just write 0c. 0, 1 in this case. Let's find an additional point. We want to stay fairly close to the vertex because the graph will either rise really quickly or decrease really quickly. So we want to stay close to the vertex. So to the right of that axis symmetry, I'm going to put 2 in. Everywhere there's an x, put 2. 2 squared is 4. We've got some multiplication we can do. 4 times 4 is 16. Negative 8 times 2 is negative 16. 16 minus 16 is 0. 0 plus 1 is 1. So that additional point is 1, 2. And we're going to plot all these points. So we got a vertex at 1, negative 3. We've got our axis symmetry. Goes through the vertex. The line x equals 1. We just found a point at 2, 1, so we can plot that point. We saw our y-intercept at 0, 1, and then we can connect these. So we've got at least 3 points. You always want at least 3 when you're graphing. Connect them with a smooth curve. Alright, you can pause the video and try this one. Alright, hopefully you can get through the A, B, C pretty easily. A is negative 1/2, B is 2, C is negative 1. Since A is negative, it's going to open down. Parabola will have a maximum, highest point. Axis symmetry, x equals negative b over 2a. So you should get x equal to 2 for your axis symmetry. And then to find the vertex, plug the 2 in. Oops. So replace x with 2 and simplify the right side. Exponents first, 2 squared is 4, and then multiply negative 1/2 times 2. Negative 2, and then 2 times 2 is 4. Negative 2 plus 4 is 2. 2 minus 1 is 1. So we have a vertex at 2, 1. To find the y-intercept, you can plug 0 in. You will always get 0c. c here is negative 1, so 0, negative 1. Now let's plot what we have so far, and then we will figure out that extra point. Alright, so we've got our vertex at 2, 1. Axis of symmetry always goes through that. So x equals 2 is our axis symmetry. We've got a y-intercept at 0, negative 1. And notice it's opening down. Now we can reflect that point, the 0, negative 1, across the axis of symmetry, and we'll get a point at 4, negative 1. Pretty sure if you put in 3 or 1, you're going to get some decimal or mixed number values. So we can connect those, and we have our parabola graphed. Again, notice it's opening down. It has a maximum point, has a vertex at 2, 1, axis symmetry, x equals 2.